Now that you have an understanding of how prediction can be used, let's take a look at one of the most popular Python libraries for doing machine learning using code. In this video, I will give you an overview of the machine learning categories in the Scikit-Learn library. To get started, let's talk about the three categories of machine learning that we'll use in this course. The first is regression, or forecasting, in which past data that is continuously measured is used to predict future trends. For buildings, forecasting is often used to predict the performance of energy meters. The next type of machine learning is classification. This method is used to predict categorical features such as the building design attributes that would be best suited for a given scenario. The last type is known as clustering, in which objects that are similar are automatically grouped together based on their attributes. A majority of people starting with machine learning in Python use the Scikit-Learn library. This library contains most of the popular open source machine learning algorithms. There are two types of algorithms in the library. The first group is known as supervised learning techniques. These models require a bunch of objects to be labeled by humans, usually an expert, with the attributes that you might want to predict. A model is then trained with these labeled data to create the ability to recognize each of the type of samples. When a new sample with unknown attributes is sent to the model, it attempts to accurately label it using its training. An example of a Scikit-Learn supervised regression model can be seen here. This model is known as the nearest neighbor algorithm, and it is used to take observations, seen here as black dots, and can create two prediction models that forecast the general trends that occur between the observations. Here you can see an example of a supervised classification model, known as a decision tree. These machine learning models will learn how to classify objects based on a threshold of the attributes of the training data. This model can then take a new sample and use its training to predict what class that object likely fits in. Supervised classification models can also be used on images. Here's an example of a bunch of images of faces in which a classification model has predicted who the person is based on being trained with thousands of images of those people. The other main category of algorithms is known as unsupervised learning techniques. These models will first try to make sense of a bunch of objects by simply using their characteristics to group them into similar clusters. A human would then use these clusters to understand general patterns in the data. This visualization is an example of various unsupervised clustering algorithms that are being applied to a bunch of two-dimensional scenarios in order to group points that are similar. You can see that the different models have different levels of accuracy in capturing clusters the same way a human might. Most data sets have many more dimensions than just two, and these algorithms are useful in grouping data for human understanding. The upcoming videos will illustrate both supervised and unsupervised learning algorithms from the Scikit library on the datasets analyzed in previous week's videos.